Yo, what up, Sci Fam? It's your boy Nickel. Today, we're going to learn about waves. So we're going to call this video an intro to waves. So our science notebook page needs to have the title, Intro to Waves, on it. We're going to explain what a wave is, look at two different types of waves, and then identify different wave attributes, such as the wavelength, the frequency, the crests, and the troughs. So let's begin our intro to waves. So what is a wave? Good question. Well, a wave transfers energy from one location to another. Now that energy can be something like a noise, a sound wave, or it could be something like a light, like an electromagnetic visible light wave. And these different waves can actually send information. Just right now, my voice is coming through your speakers, and these sound waves are transferring information from me to you. So that's an example. So there are two different types of waves, and I actually just described both of them, sound waves and light waves, but they have specific scientific terms that describe their wave shape and some of the properties about the waves. The first type of wave that we're going to identify is the transverse. So a transverse wave is one of the types of waves that most likely you've seen before that goes up and down and 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 so on. This type of wave, you can see there are multiple cycles. So if I say it starts here, then the next time it gets to that point would be one wave cycle. When I get next to that same point, there'd be one wave cycle, so on and so forth. So you can see that this wave is moving forward in this manner. It's a consistent movement moving from left to right here, and I drew an arrow at each of those sections. The one that's different than this, that's the other type of wave, is called a longitudinal wave. So if you know about, and sometimes in sports they say longitude, or if we think about a lateral pass, or I'm thinking of lines of longitude actually on the globe. A longitudinal type of wave is going to be like a slinky. You know, if you tap on one end of the slinky, the energy moves through the slinky in little bursts. So sometimes it clumps up, and then that clump moves past, and then it clumps up, and then it moves past. Let's draw what that would look like. So we're going to draw a slinky here. So we're going to draw these little loops, and then I got a bunch of them here right in a row. So there's a compression of energy, and then it spaces back out, and then compression of energy, and then it spaces back out. Now in drawing these, that just looks like a big scribble. So I'm actually going to show you a different way that we can draw these. So let's just draw it nice and spread out. And then to show where it's going to clump together, we can kind of cheat and draw some lines to show that it's clumping together right here. And we know that this happens with a slinky, for example, is that when you push on the end of the slinky in this direction, maybe you tap on the end of it, it sends that wave of energy through the slinky in a left to right direction. The one on the right, the transverse wave, we can imagine if you were to tie a rope to a wall and then move that rope up and down, or even a jump rope, it would end up having this type of curved pattern. Whereas a slinky, if you had a slinky and you tapped on the slinky, it would transfer that energy through the slinky. Okay, so let's identify some examples of each of these. So an example of a transverse wave would be light. Light travels, or behaves, I should say, like a transverse wave. And a longitudinal wave, an example of a longitudinal wave would be like a sound wave. All right, so that's just a basic introduction. And as we go further throughout this unit, we'll learn about the differences between light and sound waves and what makes them different from one another, and how they travel in different ways. Before, though, we get into the nitty-gritty there, we're just going to identify some attributes of waves, and we'll call this area, this portion, wave attributes. So to begin with here, let's draw ourselves just a simple, basic version of a wave. And we'll have it be a nice long wave here. So use some space, a couple lines in your notebook to draw yourself some waves. And I did my best to draw them as consistent and repetitive as possible there. It's not perfect, but it gets the job done. So let's take a look then at labeling some different parts of this wave. Let's see, let's find a good color. Let's go with this orange. So the very top of the wave, if we think about if you were to go up over the hill, we'd say that you crest the hill. So this top, I'm going to put a C there at the tops of the waves because these are called the crest. You can also think about this as in an ocean. If you saw the top of a wave, you could say you saw the crest of the wave. So each of those C's represents the crest. Let's choose a different color. Let's go with this blue color. And I'm going to put a letter T down here in the bottom. So the place where you put the food for animals, like on a farm, is in the trough because the trough holds water. So this part of the wave that goes in this direction here, where it would hold something as if like a ball were to roll down, the ball would sit down here in the trough. This T area is called the trough. So when describing waves, it's always important to know about the crest and the trough. You could talk about a crest being very tall and a trough being really low. Or maybe you have a crest that's opposite. Maybe you have a very low crest, and actually that's a really bad drawing of it. Let's try to do a different one over here. Maybe you have a very low crest and a low trough. So the wave wouldn't have as much energy because it's not as tall. So the crest and the trough allow us to be able to start identifying other parts of waves. For example, our first wave attribute that we're going to talk about other than the crest and the trough is the wave length. And the crest and the trough give us some types of like fixed points that we can use, some reference points that we can use to discuss what the wavelength is. And the wavelength is a distance. It's the distance of one complete wave cycle. Oh, good question. What is a wave cycle? Well, a wave cycle is either from crest to crest because it goes through one complete cycle, or it goes from trough to trough. Either one you want to look at is appropriate. So we're going to list both of those as one wave cycle. So it's either from crest to crest or from trough to trough. Now, this can be measured for a lot of different types of waves, like for example, radio waves or light waves. And the way that we measure that, since it's a distance, it's actually measured in meters. And so the ones that are really long are measured in meters or just parts of meters. And the ones that are super, super small are measured in a smaller unit for meters called nanometers. All right, so you can see how the crest and the trough become important frameworks or important reference points for us to be able to use so we know what the wavelength of a wave would be. The other wave attribute that we're going to define is the frequency of a wave. The frequency of a wave is the number of wave cycles that happen every second. So a frequency is the number of wave cycles per second. If there's more wave cycles in a second, then it's a higher frequency. If there's less wave cycles per second, then it would be lower. Then it would be lower frequency. So think about a high frequency noise. It's like a high pitch. So it's got a lot of waves in a second. Whereas a low pitch is less waves per second. So again, it's from crest to crest to crest, or it's from trough to trough to trough, or crest to crest, or trough to trough. Okay, let's do some examples down here and look at a long wavelength and a short wavelength. So first draw or label long wavelength and draw me a long wavelength wave. Should look something like this. Now the height of it could be different. Yours could maybe be something like that. That's fine too. But for this one, I'm going to do just a long wavelength. And we're going to look at in 1 second. If we know that this is the wavelength, we've measured the wavelength because we've looked at it from from crest to crest or from trough to trough. That's the wavelength. So let's draw a short wavelength wave. And we know that this one's going to be short because it's shorter than the last one. So now if we look at this one from crest to crest, it's much shorter than the one before it. And from trough to trough, it's the same length, which is still much shorter than the one before it. So we're looking at wavelength right now. Now, let me get rid of my measurement lines. Whoops, and I have to add my short wavelength wave back on here. Now we're going to look at the frequency. So I made this little box to look at what happens in 1 second. So over here, if I look at 1 second of time in this wave, you can see that there's not even one full wave here. So we would say that this one has a certain frequency, that not many waves happen in 1 second. So therefore it would be a low frequency. Because remember, frequency is the number of wave cycles per second, and there's not a lot of them per second. If this is 1 second of time, not many of them happen here in this 1 second. Whereas if we were to take the same box, which it's going to pull way too much here for me, so I'm going to have to undo a couple steps. Let's do it like this. So this here, if we look here, this is a low frequency because not many happen per second. But if we take that same box and we move it over towards a short wavelength, you can probably already see the number of waves that happen in 1 second. If I put this over here, you can see there's more waves that happen in that box in that 1 second of time. So since there's more of them, then we would say that this is a high frequency wave. And what we notice is that low frequency waves have low energy. Low energy, low frequency means that there's a long wavelength. There's a really short wavelength and high frequency. It means that there's a lot more energy and it's high energy. And I talk all like that because I'm trying to emphasize the aspect of high energy. So this is the basic information you need to know about waves. That's why we call this one the intro to waves. Adios.